Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if G is a set of all polynomials with coefficients from this set, right? So that means you have a group where we have polynomials of this kind a0 plus a1x plus a2x square and so on up to anx raised to power n, where this n this could also be any positive integer because they have not mentioned the order of the polynomials, right? And these coefficients, they all have either the value 0 or 1 or 2 or 3, and you remember these all are the elements which are there in Z4, right? The group of integers under modulo 4. So this is how they have taken the coefficients of these polynomials, and we are multiplying the polynomials in a usual way, except that we use modulo 4 to combine the coefficients. So that means the group operation here is addition modulo 4. So that means if you add 3x square plus 2x square, you get 5x square, but 5 is not present here, so you have to calculate mod 4 of it. So when you perform the calculation, it comes out to be equal to how much? When you divide 5 with 4, right, you get 1 as the remainder, so you get 1 here as the answer. So it is 1x square. So this is how you perform the operation here, correct? Now they are saying with this group operation we have to determine the order of the elements of G. Now how many elements are there in this G? We have infinite number of elements present in G. So in order to calculate the order, it is not possible for us to calculate the order for individual elements. So what else we can do? We can, here first of all, for order you require the identity element, which is the 0 polynomial, correct? That is okay. Now for the order of an element, we require the smallest positive integer such that you have m times that polynomial is equal to the 0 polynomial, correct? So here, in order to determine what is this m, let's see, m is at most 4. I say m is maximum, it can take the value of 4. Why? Because if you multiply any polynomial with 4 and then take its mod 4, you will get definitely 0, correct? So therefore m can have at most the value 4, correct? Now so if we are saying it can have at most the value of 4, so the other values could be 3, it could be 2, it could be 1. The degree cannot be 0, right? And so no element has order 3. Why it is so? It is because if you have the order 3, so you will have 3 into the coefficients, right? Because we would have 3 a0 plus a1x plus so on up to anxn, that should be equal to 0 plus 0x plus so on up to 0 raised to power x, correct? So this means 3 into every coefficient should be equal to 0 under mod 4, right? And this is possible whenever, what is ai? This is possible whenever ai is 0, because in this case you can have the values of ai either as 1, 0, 2 or 3, right? So in any case, if you have a as 0, then only you get 0 here, otherwise not. So therefore we only have the 0 polynomial in this case satisfying this condition, hence we eliminate this thing and state that no element has order 3. Why? Because the order of 0 polynomial is 1 only, right? It is not 0. So therefore we cannot take this case. What about order 2? And moreover, in the next question they are also saying to you that determine a necessary and sufficient condition for an element to have order 2. Now let's discuss about the order 2 case, and let's discuss about the condition which becomes necessary and sufficient for the order to become 2, correct? So we say if an element has order 2, in that case what does it mean? It means that you have 2 into a0 plus a1x plus so on up to anx raised to power n is equal to 0 plus 0x plus so on up to 0x raised to power n. In short, you can write it like this: 2 into ai would give you the answer as 0 under mod 4, correct? So this is only possible whenever you have ai's value as either equal to 0 or as equal to 2, correct? So that means The zero case again would give you only the zero polynomial, so let's not discuss it. And for ai is equal to 2, so that means for the order to be 2, you would have 2 into some polynomial would be 0, right? 2 into some polynomial would be 2 multiplied with each coefficient. So this is possible whenever ai is either 0 or ai is equal to 2 for all I. Hence this becomes the necessary and sufficient condition for an element to have order 2, correct? And this is what we wanted to have here. So I hope you understood this question well. That is it for this video. Thank you for watching.